Good morning, students, and welcome back to online classes. In the last class in chemistry, we discussed about chemical properties of bases and uses of bases. Today in this video lesson, we will discuss about strength of acid and base solutions pH scale. What is the pH scale? Where do we use it? How do we use it? What is its role and significance? We will discuss in detail today. When we consider water, water is slightly ionized into hydrogen ions and hydroxide ions. In pure water, the concentration of the two ions are equal. Due to this, pure water is neither acidic nor basic but neutral. As soon as we add acids in water, acids produce hydrogen ions in water and increase the excess hydrogen ions in water. But the acidic solutions contain hydroxide ions also, which comes from the ionization of water. In total, we can say that concentration of hydrogen ion on adding acids in water increases, whereas the concentration of hydroxide ions remains the same. Similarly, when bases are dissolved in water, bases produce hydroxide ions in water. This increases the excess of hydroxide ions in water, resulting in the water solution turning into basic. Even the basic solutions have hydrogen ions in them, which comes from ionization of water. At the end, we can see concentration of hydroxide ions, which is in water because of bases being dissolved, increases, whereas concentration of hydrogen ions in water remains the same. Thus, both acidic solutions as well as basic solutions contain hydrogen ion, and in the year 1909, Sorensen devised a scale on the basis of this, to which the strength of acidic as well as basic solutions could be represented by making use of hydrogen ion concentration in them. He linked the hydrogen ion concentration to simple numbers as starting from 0 to 14. A special name is given to the acid and base characteristics that a substance has as pH, where P stands for potential or potence and H stands for hydrogen. Hence, the potential of a substance to attract or release hydrogen ions is pH scale. The pH scale ranges from 0 to 14. The pH 7 is neutral, where pure water is having pH 7. Low pH value, that is from 0 to 6.9, is for acidic substances. High pH value, that starts from 7.1 to 14, is of basic solution. The closer to the ends of the scale, the stronger the solution is, either acidic if we move to left side or basic if we move to the right side. The concentration of hydrogen ion in solution is expressed in terms of pH. The pH of a solution is defined as the negative logarithm of hydrogen ions in moles per liter. Higher the concentration of hydrogen ions in water, lower will be the value of pH on pH scale. Thus, in pH scale, if we consider the center value 7, it is for neutral substances having equal hydrogen ions and hydroxide ions. When we consider hydrochloric acid, like all other acids, it also contains hydrogen ion in solution. Hence, the more hydrogen ion in the solution, the smaller pH value, and it will have the pH scale value near 1 and will be a strong acid. Less hydrogen ion in water in solution will result in more value of pH on scale and will be weak acid. If we consider sodium hydroxide, bases do not contain hydrogen, but hydroxide ions of the bases will have less H plus ion in the solution. As a result, the bigger the pH number, we will have the value of sodium hydroxide on scale around to its right side, that is 14. Little hydrogen ion, bigger the pH value. Less hydrogen ion will be the more high pH number will be of weak bases. This pH color chart shows how the color of the particular universal indicator paper changes with the solution of different pH values. We have common indicators. These common indicators tell us whether the given substance is an acid or a base. These cannot tell us whether the given substance is a strong acid, a weak acid, a strong base, or a weak base. So, common indicators needed to be shifted to replace to universal indicator. So, to obtain an idea of how acidic or basic a substance is, universal indicator is used. Universal indicator is a mixture of many different indicators or dyes which gives different colors at different pH values of the entire pH scale. As the scale starts from 0 to 14, ranges from 0 to 14, similarly, different colors are for the different pH values. If we consider the substances or the solution more acidic, it will be to the left side, and if more alkaline or basic, it will be to the right side. Water will produce a green color with the universal indicator. Hence, we say water is neutral in state. This makers of universal indicator provide a pH color chart to compare the color produced on the indicator paper on adding acid or base solution and find out its pH value. Just like litmus or any other indicator, universal indicator can be used either in the form of a solution or in the form of universal indicator paper. In laboratories, we generally use universal indicator papers to identify the strength of acid and base solutions.